Hello and welcome to Algebra 1, Lesson 62. In this video, we're going to learn about solving quadratic equations using the quadratic formula. So when we first started learning about quadratic equations, we only dealt with quadratic equations that we could solve via factoring. And we kept it that way for a while. And then in the last lesson, we learned how to solve a quadratic equation, whether we could factor it or not, using a process known as completing the square. Now, completing the square is one of those things where it's very, very tedious, and there's so many steps involved, it's very easy to make a mistake. So in this lesson, we're going to look at an easier process to solve any quadratic equation that you're going to come across. So this is known as solving a quadratic equation using the quadratic formula. But before we begin using the formula, let's take a look at where it actually comes from. So we see ax squared plus bx plus c equals 0. This is standard form. And of course, this is a generic example. All I'm looking at here is I have my squared variable first, my variable to the first power second, and then my constant third. So I could have something like 6x squared plus 2x minus 7 equals 0. This is standard form. And one of the things we're going to have to do is match things up. So in other words, this right here, the coefficient for x squared, that's a. This 2 right here, the coefficient for x to the first power, that's b. This negative 7 is going to be c, or the constant term. And it's very important that you include the sign with this because, remember, I could write this as a plus and then a negative 7. Okay, so that c there is negative 7. And the variable does not have to be x. Again, that's just a generic example. You could see something like 3m squared plus 4m minus 2 equals 0. Now you have 3 as the coefficient for m squared, so 3 is a. 4 is the coefficient for m to the first power, so 4 is b. And then negative 2 would be c. That's your constant. Now, let me erase this real quick. And I want to show you how to derive the quadratic formula. And after that, we're going to look at some examples using the quadratic formula. And you do a few examples of that, and basically you're good to go. Right? You're just plugging things in. As long as you can do some basic arithmetic, you're good to go. So for this guy right here, ax squared plus bx plus c equals 0, what is the solution? And I realize we don't have numbers. We have an a, b, and a c that represent numbers. But how would I get a solution? Well, we know already that we can use completing the square. So let's go ahead and do that. Let's start out by doing what? Let's just copy this. Ax squared plus bx plus c equals 0. I know I want all the variable terms on one side. These are the variable terms. And I want my constant on the other. So I got to move that over. So how to do that? Again, I just subtract c away from each side of the equation. So I would have ax squared plus bx is equal to negative c. Right, this is going to cancel. So once I've done that, the next thing that I've told you is that you always want the coefficient out here to be a 1. Now, when you use a generic example like this, you have a that represents your coefficient. A could be 1. A could really be any number that you choose. It just can't be 0. Because if I had a 0 here, let's say I put 0 there. 0 times x squared is 0. You no longer have a quadratic equation. So actually, that's one restriction that you have with a quadratic equation. Your a, or your coefficient for the squared variable, cannot be 0. Right now, a can be anything other than 0. So to deal with that, we're going to get rid of a from right there. And I do that with some basic algebra. I divide both sides of the equation by a. And what happens is it's going to cancel here. And now the coefficient for x squared is definitely 1. So I have x squared plus b over a times x is equal to negative c over a. So the next step is the one that everybody struggles with. We're going to complete the square. Now let me just copy this real quick. I'm going to move it down. I have some room. And to complete the square, I take 1/2 of the coefficient of the first degree term, and I square it. Okay, and then I'm going to add that to both sides. So this is the coefficient for the first degree term. This is x to the first power, and this is your coefficient. And again, when we work with kind of generic examples, it's hard to see that, right? But this is your variable here. X is the variable, b over a is the coefficient. So I want to cut it in half. So I'll multiply it by half, and then I want to square it. So this would be b over 2a, b over 2a. And if I squared that, b squared is b squared, and then 2 squared is 4, a squared is a squared. So this is the value that I'm going to add to each side of the equation. So let me just kind of slide this down. And so I'm going to add b squared over 4a squared to both sides of the equation. Now, on the right side of the equation, I want to get a common denominator going. So how can I do that? Well, here I have 4a squared. Here I just have a. So if I multiplied by 4a, top and bottom here, I would get, let me kind of do this down here, b squared minus 4a times c is 4ac, all over, this would now be a common denominator of 4a squared. Okay, so the right side, that's good to go. So now the left side is a perfect square trinomial. So we're going to factor this guy. We know the first position would be x, and then there's a plus there. And then in this position, the square root of b squared is b. The square root of 4a squared is 2a. So now what I want to do is use my square root property. I'm going to take the square root of this side, and I'm going to go plus or minus the square root of this side. And of course, this is going to cancel with this. And I'm going to have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. All right, let's scroll down. And one of the things we can do is we can break this up, right? I know if I have the square root of, let's say, 1/4, this is equal to the square root of 1 over the square root of 4, which is equal to 1 over 2 or 1/2. So I can do the same thing here. So I can write this as plus or minus, that can stay just with the numerator, the square root of b squared minus 4ac over the square root of 4a squared. And over here on the left, this isn't going to change. We just have x plus b over 2a. Now, why did I say this can just stay in the numerator? Well, just assume for a minute that everything was positive, right? I have the positive version. Well, nothing would change. Let me just erase that real quick. You would just have this over this. If I had the negative version, well, only one of them can be negative. If I had a negative over a negative, well, then that's going to give me a positive. So when you have this plus or minus, it's really just out in front saying I have a positive version of this and a negative version of this. So you really want one plus or minus. Okay, so I just stick that in front of the numerator. Now, in the denominator, the square root of 4a squared would be 2a. So how can I get x by itself? Well, I can just subtract b over 2a away from each side of the equation. And let me scroll down a little bit. What we're going to have here, this will cancel, is x is equal to, I'll have negative b over 2a, then I'll put plus, I'll have plus or minus the square root of b squared minus 4ac over 2a. Now, I have a common denominator here. I have 2a here and 2a here. So really, I can write this in a more compact form, and in the format you're going to see in your textbook, as x is equal to negative b plus or minus the square root of b squared minus 4ac over the common denominator of 2a. And you might say, well, yeah, you solved it for x, but what is this? This looks like a bunch of nonsense. All I need to do to get the solution for a quadratic equation is plug in. So you remember when we saw the quadratic equation in standard form that a, b, and c represented real numbers, right? It's just a restriction where a cannot be 0. But if I plug in for a, b, and c, I'm going to get a solution for my quadratic equation. So let me copy this real quick. And we're going to go down. And I'm going to label this as the quadratic formula. And let me just give you a quick example before we start kind of going into some more detail here. If I saw something easy like x squared minus 5x plus 6 equals 0, this is something we can solve with factoring. So two integers whose sum is going to be negative 5 and whose product is 6 would be negative 2 and negative 3. So we can look at this at this point and hopefully know that the solutions would be x equals 2 or x equals 3. Right? I'd set each one of these equal to 0 and I'd solve. If I plugged into the quadratic formula, all I would need to do is say, okay, a generic quadratic equation in standard form is ax squared plus bx plus c equals 0. So in this case, a is equal to what? It's equal to 1. B is equal to what? It's equal to negative 5. And c is equal to what? It's equal to 6. Right? I'm just lining things up with that generic example. So now I would just plug into the formula. So I would have x is equal to negative b. The negative of negative 5 is positive 5. So I'd have negative 5. Again, that's positive 5. Then you have plus or minus. So I'm going to do the positive scenario first. So plus the square root of, you have b squared, negative 5 squared is 25, minus 4 times a times c. 4 times 1 is 4, times 6 is 24. Then this is all over 2 times a. A in this case is 1, so all over 2. So 25 minus 24 is 1. So you'd have the square root of 1, which is 1. So 5 plus 1 is 6. So you'd have 6 over 2, which equals 3, which is one of your solutions right there. Now, if we do the negative scenario, you'd have, again, negative b. So negative of negative 5 is 5. Then minus the square root of, we know this is going to be the same. B squared, you have negative 5 squared, that's 25, minus 4 times a is 1, times c is 6. So 4 times 1 times 6 is 24. So this ends up being the square root of 1 again. So this is 1. Over 2 times a, again, a is 1, so over 2. 5 minus 1 is 4. 4 over 2 is 2. So that's 2, and that's how we get our other solution right there. So you can see that plugging into the quadratic formula is pretty easy. I don't need to factor anything. I don't need to complete any squares. I don't need to do anything other than line up my equation in standard form, figure out what A is, B is, and C is, and then plug in and get an answer. Okay, it's very, very simple. All right, so let's go through some technical details. So b squared minus 4ac, this is the part that's under the square root symbol, is called the discriminant. Write that down. Very, very important, and it comes up a lot, especially when you get into Algebra 2 and college algebra. If b squared minus 4ac equals 0, there is one solution. One solution, okay? If b squared minus 4ac is greater than 0, like we just had in the last example, there are two solutions, okay? Two solutions. And then if b squared minus 4ac is less than 0, there is no real solution. No real solution. And in some Algebra 1 courses, you're going to deal with negative square roots. In other Algebra 1 courses like this one, I'm not going to take it on. I'm going to wait for Algebra 2 so that you can completely understand what's going on. I've taught in Algebra 1 before, and I feel like students just don't have a good enough understanding of the basic processes to get into that. So in the next course I'm going to do, which is Algebra 2, we are going to talk about what to do when b squared minus 4ac is less than 0. There is a solution for it, but it involves the complex number system, which we just haven't covered yet. All right, so let's take a look at some practice problems. So we have 4x squared minus 5x equals 6. The first thing I'm going to do is I'm going to write the generic form for the quadratic equation in standard form. You should have this on a flashcard, and it should be something that you memorize. So it's ax squared plus bx plus c is equal to 0. Now, this guy right here does not match this guy, okay? What we need to do is move our constant term over to the left. And again, we do that with basic algebra. We just subtract 6 away from each side of the equation. And I'm going to have, and let me just write it over here, 4x squared minus 5x. I subtracted 6 away, so minus 6. This would cancel, so equals 0. Now, the next thing that I want to do is line everything up, and I want to figure out what is A, what is B, and what is C. Okay, I need those to plug into the formula. So A is the coefficient for the x squared, so that's 4. B is the coefficient for the x to the first power, so that's negative 5. You need the negative there, don't just put 5. And then C is negative 6. It's the constant. You need the negative, don't just put 6. So once we have this information, we plug it into the quadratic formula. So again, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac. This is all over 2a. So what are we going to have here? We'll have x is equal to negative b. So I put negative, and then for b I put negative 5 in there, plus or minus the square root of, we have b squared. So let's put negative 5, and let's square that, minus 4 times a, that's 4, times c, that's negative 6. And this is all over 2 times a. A is 4, so 2 times 4. All right, so this is the first scenario. So then x is equal to, the negative of negative 5 is 5, plus the square root of negative 5 squared is 25, minus 4 times 4 is 16. 16 times negative 6 is negative 96. So you'd have minus negative 96 or plus 96. So if I add these two together, I'm going to get 121. Then this is over. 2 times 4 is 8. Now, what we just talked about was that if the result of this in here is greater than 0, I'm going to have two solutions. If it equals 0, I have one solution. Why is that the case? Because the square root of 0 would be 0. This would be gone. And I just have, in this case, if that did happen, I'd have 5 over 8. Okay, that's not the case here. I have the square root of 121, which is 11. So this is 11. 5 plus 11 is 16. 16 over 8 is 2. So I get x equals 2 as one of my solutions. Then for the other solution, this would all be the same. So negative of negative 5 is 5. I'd use minus now. So minus the square root of, we know this turns out to be 121. So let's just put minus 11 over 8. So 5 minus 11 is negative 6. So this would be negative 6 over 8, which would reduce to negative 3/4. So we get x equals negative 3/4. Okay, so pretty easy overall. Let me erase all this. With these, they're pretty tedious to check, so I'm not going to check all of them, but I am going to check one of them. So let's go ahead and check this one. So we know how to check things at this point. We take our answer, which in this case is 2 for x, and we plug it in. So plug a 2 in there and there. We'll make sure the left and the right side are equal. So 4 times 2 squared would be 4, minus 5 times 2 should be equal to 6. 4 times 4 is 16. 5 times 2 is 10. 16 minus 10 is 6. So you get 6 equals 6. So this solution does check out. Then the other one is negative 3/4. So let's erase this. And so we have 4 times, you'd have negative 3/4, and this is squared. And then minus 5 times negative 3/4, and this equals 6. So if I squared this guy, I'd have 9/16. So times 9/16. And of course, this would cancel with this and give me a 4. So I'd have 9/4 there. You have basically negative 5 times negative 3/4. Negative 5 times negative 3 is positive 15 over 4 equals 6. 9 plus 15 is 24. You'd have 24 over 4, which is 6. Again, you get 6 equals 6. So this checks out as well. So x here is equal to 2, or x is equal to negative 3/4. Okay, let's go ahead and take a look at the next example. So we have 5r squared is equal to negative 10r minus 5. So the main thing here is that you don't want to get confused because the variable is not an x. Okay, it doesn't matter if you have an x, an r, a q, a z, whatever it is. You just follow the generic formula. So if I have ax squared plus bx plus c equals 0, I could rewrite this as ar squared plus br plus c equals 0. It doesn't matter what the variable is. We're just saying that we need to figure out what a is, b is, and c is, so we can plug it into that formula, okay? So what I want to do is move these two terms over here, and I'm going to do that by adding 10r to each side of the equation, and I'm going to add 5 to each side of the equation. So I would have 5r squared plus 10r plus 5 is equal to 0. And then I can see that my a would be 5. This is a. My b would be 10. This is b. And my c would be 5. This is c. All right, so once I know that, I can plug into the quadratic formula. Let me scroll down. And for that quadratic formula, it's usually x is equal to, but let's just say r is equal to negative b plus or minus the square root of b squared minus 4ac. This is all over 2a. All right, so I'm going to plug in for b. So I'm going to plug in a 10 here. And I'm going to be plugging in a 10 here. So 10 squared, let's just go ahead and put 100. And then minus 4ac. So a is 5, c is 5. So minus 4 times 5 times 5. And then this is over 2a. A is 5, so 2 times 5 is 10. Now the one thing you're going to notice here is that 4 times 5 is 20, 20 times 5 is 100. 100 minus 100 is 0. Square root of 0 is 0. So do I need plus or minus 0? No. Because if I add 0 or I subtract 0, I'm not doing anything, right? It's not going to change anything. So you can erase this. And I told you that a minute ago. If b squared minus 4ac, if the discriminant, as it's called, is equal to 0, you're going to have only one solution. So here, r is equal to negative 10 over 10, which is negative 1. And that's a simple one to check, so let's go ahead and do that. So again, r is equal to negative 1. So if I plug that in here and here, I'd have 5 times negative 1 squared is equal to negative 10 times negative 1 minus 5. Negative 1 squared is 1. 5 times 1 is 5. And this equals negative 10 times negative 1 is 10. And then minus 5. 10 minus 5 is 5, so you get 5 equals 5. So this solution checks out. R is equal to negative 1. All right, let's take a look at another one. So we have 18x squared minus 10x minus 2 is equal to 9x squared minus 4x minus 10. Really all I have to do is subtract 9x squared away from each side of the equation. That'll cancel. Add 4x to each side of the equation. That'll cancel. And add 10 to each side of the equation. That'll cancel over there. So I'd have 18x squared minus 9x squared is 9x squared. Negative 10x plus 4x is negative 6x. Negative 2 plus 10 is positive 8. And this equals 0. And so this is in standard form, right? We have ax squared plus bx plus c equals 0. We have a is 9, b is negative 6, and c is 8. So if I plug into my quadratic formula, what am I going to get? I get that x is equal to negative b. So in this case, b is negative 6. So the negative of negative 6 is plus 6. Plus or minus the square root of b squared. If I squared negative 6, I get 36. Minus 4 times a. A is 9. 4 times 9 is 36. Times c. C is 8. So 36 times 8 is 288. Now you already can see you're going to have a problem, but let's continue. This is over 2 times a. A is 9, so 2 times 9 is 18. Now, why did I say that you're going to have a problem? If 36 minus 288 is a negative value, and it's negative 252, can I take the square root of a negative number? Well, I can, but not yet. The solution is not a real number. In this particular case, we'd stop and say there's no real solution. Okay? So this is going to come up pretty often until you start dealing with complex numbers, and then you actually will be able to get a solution. But we haven't gotten to that yet. So for right now, we just stop and say there's no real solution. All right, let's take a look at another. So we have negative 5x squared minus 6x minus 19 equals negative 2 minus 8x squared. So I'm going to add 8x squared to each side of the equation. That'll cancel. I'm going to add 2 to each side of the equation. That'll cancel. So I'll have 0 on the right. On the left, 8x squared minus 5x squared is 3x squared. Minus 6x, and then negative 19 plus 2 is negative 17. And at this point, you should be kind of getting this. This is ax squared plus bx plus c equals 0. A is the coefficient for the squared variable. B is the coefficient for the variable to the first power. And then c is the constant. Okay? Make sure you include the negatives, otherwise you won't get the right answer. All right. So the quadratic formula. Remember, it's x is equal to the negative of b. B is negative 6. So the negative of negative 6 is plus 6. Plus or minus the square root of b squared. If I square b, I get 36. Minus 4 times a. A is 3. 4 times 3 is 12. Times c. 12 times negative 17 is negative 204. So minus the negative 204 is plus 204. So I would get 36 plus 204, which is 240. So this is plus or minus the square root of 240. And this is over 2 times a is 3, so 2 times 3 would be 6. All right. So now, what is the square root of 240? Well, 240 is not a perfect square. So here we get something that's going to be kind of messy. So for 240, I'll factor that to 24 times 10. And let me factor this into 6 times 4. I know this is 5 times 2. This is 2 times 2. And this is 3 times 2. So I have 1, 2, 3, 4 factors of 2. So I'm going to have 16 times 15. 16 times 15. So I know 16 is a perfect square. Square root of 16 would be 4. So basically I could write this as 4 times the square root of 15. Now I just have two scenarios. I will have x is equal to 6 plus 4 times square root of 15 over 6. Then or x equals 6 minus, okay, let me scroll down, 4 times the square root of 15 over 6. And we can further simplify these. What we can do is we can factor 2 from the numerator. So I can put 2 times 3 plus 2 times square root of 15 over 2 times 3. So this would cancel with this, and I'd be left with 3 plus 2 times square root of 15 over 3. It'd be the same thing over here. If I canceled a common factor of 2, this would be a 3, this would be a 2, and this would be a 3 down here. So I can have x equals 3 plus 2 times square root of 15 over 3, or x equals 3 minus 2 times square root of 15 over 3. Those would be your two solutions. And of course, you could write that in a more compact format by just saying x equals 3 plus or minus 2 times square root of 15 over 3. Now, I could check this answer, but in the interest of time, I'm not, because something like that gets really, really tedious. If you want some practice, and I think it is good to practice with things like that, pause the video, take each one of these and plug it in for x in the original equation, and see that you get the left and the right side as the same value.